can appreciate with the amount of stuff that goes on around the globe, it's actually quite tricky to find a time when we're going to have all 16 study committee, all 16 panel members in Australia at one point in time. In fact, we find it so difficult that the only reliable way to have a face-to-face meeting is in the Paris session every 2 years. So I go to Paris just so I can meet the people on my technical committee. All jokes aside, we're going to go now on to the next of our C panels. So James Hart's going to talk to us about C3.
Thank you, everyone. James Hart, convener of the C3 panel. The scope of C3, it looks at the environmental impacts associated with electrical power systems. In terms of our activities this year, we had our symposium in June in Denmark with a number of other committees. We've got 12 active working groups and one reference group. That reference group at the top was a working group previously, and it was a perpetual one. It was the only perpetual Seagrey working group, and I think it must have stuffed up their stats on working groups, so it's now a reference group. Most of my time with C3 this year has been spent on C3.19, which is a working group that I'm convening, and that one's due to wrap up by the end of this year, hopefully. Instead of going through all of the working groups, I was just going to cover off on a few issues that may be of interest, and I'll start with EMF because it's my working group. EMF, you've essentially got three issues. So the first one is to do with the magnetic fields causing flashes of light in the eye and the electric fields causing microshocks. So there's guidelines in place to address those, protect against those effects, which you probably can't read over the side. Most people would know of the 200 microtesla for the public and the 1,000 microtesla for workers, but in fact there's quite a number of limits depending on what part of the body is exposed and so forth. There are a number of areas within our networks which do exceed these guidelines, and we need to put measures in place to protect our workers for those. That's some live work. I think that's in France. And you can see an ammeter around the bus bar there. So the workers are monitoring the current in the bus bar. When it exceeds a certain level, they're to stop work and move away. The second issue with EMF is medical implants. Now, they're not covered by any of the standards, primarily because there's so many manufacturers and so many different types, and it's really patient-specific. So that issue is managed by workers coming to their employer and saying, I've got this device and here are the immunity levels, and then if required, doing a workplace assessment. The last issue with EMF is the childhood leukemia issue, and this is the most controversial issue of the brochure, only because there's so many different views on this. You've got countries like Canada that say nothing is required, and then you've got countries like Italy that set limits well below the guidelines. Now, most countries are somewhere in between, and in Australia we've got a long-standing policy of prudent avoidance. So if we can reduce exposure at no cost or low cost, we believe it's a sensible thing to do. Now, in Sydney we had a project a few years ago. We were replacing a double circuit 132 kV line. Now, the edges of that graph roughly represent the property boundaries. So these cables are laid in the middle of the road mostly, but sometimes they move around a bit. And what we went to with the community was a trefoil type arrangement which was optimally phased. Now, for a number of reasons, this project created a lot of attention in the community. They had local barbecues and rallies and letterbox drops, and they were demanding less than 2 milligauss at all property boundaries. And we were taking the position there's no basis for specific limits, but if there's some low-cost measures, we'll look at it. We looked at reconfiguring the downstream network, so more balancing the loads on both of these circuits. That was met with a bit of scepticism with the community. And in fact, it wasn't going to achieve their limit of 2 milligauss at the boundary because the cables weren't always in the middle of the road. It was at this point that I was speaking with a Seagrey colleague, and and he suggested having a look at a technical brochure and inverting one of the trefoils, which is that type of arrangement. And you can see we end up with quite a substantial reduction there, down to less than what you'd call background levels. So we did the ratings calculations, and I believe they actually had better thermal rating than the previous design. And we had to design a bracket for the cable, for the conduits to hold, and that's now become our standard design. So that's a good example of the benefit of Seagrate. Next issue I just wanted to touch on was oil-filled cables, and this is courtesy of B1 over there. Up on the left there, I think that's in the 60s, so that's a cable being installed across Sydney Harbour, oil-filled cable. You can see down the bottom there an example of what one looks like. So they've got a hollow centre, and that's full of oil, roughly about 2 litres per metre, and it's under slight pressure. We've got a joint bay, and you can see some of the tanks that are at either end of the cable. Now, one thing with any container holding liquid, whether it's a drum or a tank or a cable, eventually it's going to leak. And this has created a lot of issues for companies around the world. And these could leak because of, we've had cases of termites eating the cables, corrosion, you've got third-party strikes. It's a really big issue, and for some companies, arguably, it's their biggest environmental issue. So what a number of companies are doing is applying a risk model to their cables. So looking at the cables' likely oil loss, the sensitivity of the environment, and actually calculating the risk for each of the cables. This then feeds into the replacement programs, and we can set targets based on reducing the risk by a certain percentage every year. Next issue, at our meeting, I should come back, another benefit of Seagrate. One of the issues with these cables is decommissioning. So they're all installed in the 60s and 70s, so we're getting a wave of decommissionings hitting us at the moment. And the issue is getting the oil out of the cables. In some countries overseas, they're required to pull the cables up, which is not a position we'd want to be in. At a recent, or not a recent one, a few years ago, I attended a Seagrate meeting, and previously we'd push air through the cables, nitrogen, and we'd extract about 60% of the oil. Another country, we're using water, and we since trialled the water, and we're actually getting close to 100% out of that core of the oil extracted. The environmental legislation is very complex, and it's getting more complex. We've got about 40 acts in New South Wales. We've got about 10 regulators. There's literally hundreds of considerations if we want to build a project. And the penalties now are over $10 million, and managers and directors are liable. So we really need good tools and systems in place to identify those requirements. This is an example of one. They're very similar ones around the country, but this is actually Kurnell. If you ever fly into Sydney Airport, you'll probably end up flying over this substation there. And Kurnell is an unusual place. There's a desalination plant, you've got a sewage treatment works, you've got a refinery, there's a sand mine, and you're under a flight path. But it's actually very sensitive in terms of environment. And these tools have developed such that we're now linking into the regulators' databases and internal databases. If I was to click on that H there, which is hazardous materials, there's a link to our internal asbestos register, and I can get a copy of the latest audit report. So these substations are audited every 5 years, and I can see where the known asbestos is within that substation. And this tool is also available on the iPads for the guys out in the field. So it's quite useful. If I'm planning a project, I just select the area, and then I can run a report, and it will tell me all the issues within that area and what the requirements are. So I was saying it was quite a sensitive area. We've got contamination, we've got Ramsar wetlands, endangered communities, mangroves, an aquatic reserve, acid sulphate soils, we've got our asbestos, there's Aboriginal heritage, a national park, and there's an RMS classified road, all within that substation area. Now, I mentioned asbestos. That's the last issue I just wanted to talk about. Again, asbestos was widely used around the 60s and 70s, so a lot of equipment now coming out of service. We really need to give consideration to asbestos. And here's some finds that we've had recently in tap changes, in the gaskets, in the brake shoe pads, meters and relays. The mastic holding the glass panel onto the cover contains asbestos in some of those, even some domestic meters. We've had paint on wood poles, paint on steel towers. I believe there's one company in Australia that has over 1,000 steel towers that were painted with asbestos paint, and they're spending tens of millions of dollars to remove that. We've got ripple filters. I don't know what a Burco resistor is. I'm sure someone here does. A Westinghouse relay. Another emerging issue is this recycled spoil or recovered fines in aggregate. The engineers love it because it's really good compaction properties and it's cheap, but you never really know where the source is. And we've had countless examples of companies that have put crushed sandstone on access tracks, identified asbestos, the whole lot has to be ripped up. Other cases where the material bay was found to have asbestos, and that soil had been used at multiple sites, across the city, and that all has to be recovered. So it's very important to be aware of this issue and ensure that your processes capture any asbestos before any of this stuff gets sent to a recycler, which has also happened, or before anyone starts sandblasting a tower. That's it. Thank you.
Is it